Hello friends, good morning everybody. Today in this session, we'll study some theorems about continuous functions in two matrix spaces and examples. Okay. So our first theorem is composition of two continuous functions is continuous. Okay. So what is the theorem? Composition of two continuous functions is continuous. Two continuous functions is continuous. So let f from xd to y row with usual notation and g from y row to z sigma be continuous functions. Be continuous functions. What is our claim? G composite f from x to z is continuous. G composite f from x to z, xd to z sigma is continuous function. So we'll take, let G be the open subset of Z. Let G be open subset of Z. Then we show that G composite F inverse G is open in X. Okay. Then G inverse G is open in Y. Since G is continuous function. Which implies F inverse of G inverse G, which is equal to F inverse composite G inverse, or is open in X since F is continuous function. So inverse image of continuous open set is open. So we'll give 1 for this. Now G composite F inverse G, which is equal to inverse of composite of maps is same as F inverse composite G inverse G, which is nothing but F inverse of G inverse G is open in X. For any open subset G of Z, and therefore by sufficient condition G composite F is continuous function. xd to z sigma is continuous function. Right? Next theorem, let fg from xd to y row be continuous functions and AB Dane subset of AB Dane subset of X let fx equal to gx for every x belongs to A. Then fx equal to gx or then f is equal to g. That is to show fx equal to gx for every x belongs to x. F is equal to g on x. Now since A Danes in matrix space X, therefore A closure is equal to X. 1. Since f and g are continuous functions, since fg from x to y are continuous functions, therefore set of x belongs to x such that fx equal to gx. We have taken one lemma is closed set in X. This is the closed set, and then this set is closed in X. Therefore, A is equal to A closure is equal to A. From 1 and 2, A is equal to X. A is equal to X. Okay. And therefore, fx equal to gx for every x belongs to A is equal to X. Therefore, f is equal to g function. F equal to g. Is it clear? Now take the theorem. Let XD be metric space. Be a metric space. Then the function f from x to r u. Then the function f from x to r u defined as fx is equal to and a b subset of x. Sorry, fx equal to d of xa is uniformly continuous. Uniformly continuous. So given f from xd to ru is defined as fx is equal to distance between x and a for subset x belongs to x and for fixed subset a of x, subset a of x. Claim f is uniformly continuous. F is uniformly continuous means what we have to show? That is to show for given epsilon greater than 0, there exists some delta greater than 0 such that mod of f of xa minus f of ya, sorry, mod of fx f of y is equal to mod of d of xa minus d of ya is less than epsilon whenever distance between xy is less than delta xy belongs to x. For any 2 points in x, if our distance less than delta, then distance between their images under this function f must be less than epsilon. That is our aim. Okay. But what is the d of xa? D of xa is nothing but infimum of d of xa where a is in a. Okay. So for this, by triangle inequality, d of xa is less equal d of x y plus d of ya, right? For any x y belongs to x and a belongs to a contained in x. We are getting this, which implies this. Therefore, if you take infimum of d of xa where a value is in a, this must be less equal d of xy plus infimum of d of ya where a value is in a. A value is in a. Okay. But this is nothing but distance between x and a is less equal d of xy plus d of ya. Therefore, d of xa minus d of ya is less equal d of xy. We'll get 1. Right. Interchanging x and y. Interchanging xy in 1 we get d of ya minus d of xa is less equal d of yx, but by symmetry this is nothing but d of xy, right? And therefore minus of d of xa minus d of ya is less equal d of xy. From 1 and 2, plus minus this less equal d of xy. Okay. From 1 and 2, what will get? Mod d of xa minus d of y is less than d of xy. From 1 to mod of d of xa minus d of ya less equal to of xy for any xy belongs to x. This is now say 3. So from this, for given this is equivalent to mod fx minus fy is less equal to of xy for any xy belongs to x. So from this, for given epsilon greater than 0, for given epsilon greater than 0, there exists delta is equal to epsilon greater than 0 such that mod of fx minus fy is less equal to of xy is less than delta is equal to epsilon whenever d of xy is less than delta xy belongs to x. Whatever 2 points within a distance less than delta implies mod fx minus fy is less than epsilon. This implies f is uniformly continuous function. F is uniformly continuous function. Now take the example. Let XD be metric space. Here we are taking A to be subset of X. Here we will take X naught to be fixed point and X naught belongs to X be fixed. Define function f to the suffix x naught from x to Ru as fx naught x is equal to d of xx naught. D of xx naught, x belongs to x. Show that fx naught is uniformly continuous. Uniformly continuous function. On same line, we can solve this example. Okay. So solution by triangle inequality of matrix D. We have D of xx naught is less equal to d of xy plus d of yx naught. For xy belongs to x naught and x naught belongs to x fixed. What this implies? This implies d of x naught minus d of y naught yx naught is less equal to of xy. Interchanging x and y, interchange x and y, we get d of yx naught minus d of xx naught is less equal to of yx, but by symmetry this is nothing but d of xy. This is equivalent to minus of d of xx naught minus d of y naught, yx naught, mod, yes, minus of this is less equal d of xy. From 1 and 2, from 1 and 2, we get from 1 and 2, we get mod of dxx naught minus dyy naught is less equal to of xy, and this is equivalent to mod of fx naught x minus fx, sorry, here x naught again, y is less equal to of xy, okay, for xy belongs to x. This is 2. 3. By definition of f of x naught, fx naught function. Okay. So from this, for given epsilon greater than 0, for given epsilon greater than 0, for any epsilon greater than 0, there exists delta is equal to epsilon greater than 0 such that mod of fx naught x minus fx naught y is less equal to of xy is less than delta is equal to epsilon whenever d of xy is less than delta, xy belongs to x, whatever that 2 points may be. This implies is fx naught function is uniformly continuous. Fx naught function is uniformly continuous function. So with this discussion, today we'll stop our session here. If you like the session, subscribe the channel. Your like gives motivation to develop such type of online video lectures for you. Thanks for listening lecture carefully. Bye bye.